Hello and welcome to the Daily Space for today, Thursday, November 19th, 2020. I'm your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain. But before we talk science, I want to take a minute to acknowledge that 2020 is 2020. And if our show is a little raw around the edges, it's because we as humans are more than a little raw around the edges. All of us who put this show together do it as a labor of love, but we have additional jobs and responsibilities beyond this show. Currently, Allie, who also works at a private boarding school, is watching the kids she works with get sent home, including getting sent home abroad in some cases, as COVID builds an inroad into her campus's community. Here in Madison County, Illinois, we saw our COVID rates double 3 weeks ago and then triple this weekend as we went from 50 cases a day to now 600 in our rural Illinois setting. And we're getting run over by a disease that is more than pleased with the lack of a local mask mandate. Annie and I have been stocking up in food and supplies as we see the writing on the wall and prepare for the stay-at-home order we are pretty sure is coming. Beth is in California, and there the cases are climbing and restrictions are being tightened again. And she has a teenage son. She is helping survive a freshman year in high school while he's distance learning. And we all know how hard high school is, even in the best of circumstances. All of us are trying to figure out how to deal with the holidays alone, plunging temperatures and too much isolation in these ever longer winter is coming nights. It is really, really hard to focus on science communications when you're worried about the mental and physical health of those you love most. We keep going because we know that escaping into science and mentally escaping into space is one of the few escapes we still have. We do this because the community built around this show and all our other CosmoQuest productions is a community that has come to be our family. And sometimes you put on a smile and keep going when you're leaders of a family so that you can give everyone else the courage to keep going too. But it's hard. And we need to acknowledge that. We don't know when normal will return. COVID mitigations at NASA are cutting into the money available to researchers through grants. There will be less science. The closing of observatories to allow people to work at home is changing the rate of data collection. There will be less science. The need to homeschool, to bring home elder relatives to care for them at home, the malaise of not knowing what is coming or when the next new bad news will arrive. It all means less science. Scientists are human. But we're all going to keep going, somehow. One cup of coffee and pause to cry off screen, and one panic-eaten box of Triscuits at a time. We're somehow going to keep going. And now I'm going to keep going with today's top news story. 16 years ago, astronomers using the ultraviolet sensitive Galax Space Telescope discovered a super weird UV shining nebula surrounding a normal enough looking star. Now, this is referred to as a blue nebula in pretty much all the press releases out there. And this is because in the false color images that were created, ones like the one that we're showing you right here, the ultraviolet light, which on the rainbow is like beyond purple, so more blue than blue. Since our eye can't see that color, it has always been put into the false color images as blue. This nebula is not blue, this nebula is ultraviolet, and that is super weird. Normally, nebulas give off light in a myriad of different colors. They're warm and have some continuum to them. But this one, it's just hanging out there being ultraviolet. And trying to figure out what it is has been super difficult. For 16 years, researchers have tried model after model, theory after theory, and as they looked at this object in telescope after telescope using progressively bigger systems, observing it more wasn't helping. And this is where folks turned to a theorist. And that theorist was able to say, well, if two stars merge and they leave behind a star in the center, which is what we see here, you can potentially get a nebula the size of a supernova nebula, which is again what we see here. And it will last only a brief period of time, meaning you won't see it very often, and this is the only one we've seen. And it will fluoresce like the nebulosity seen trailing behind the fast-moving star Mira, Omicron Ceti. And that shade of fluorescing ultraviolet light is what we see here. According to lead study author Carrie Hoodley, the merging of stars is fairly common, but they quickly become obscured by lots of dust as the ejecta from them expands and cools in space, which means we can't see what has actually happened. We think this object represents a late stage of these transient events when the dust finally clears and we have a good view. But we also caught the process before it was too far along. After time, the nebula will dissolve into the interstellar nebula, and we would not be able to tell anything had happened at all. This is a fancy way of saying this is something that has probably happened over and over throughout our universe. That myth that those of you who are older like me were told early on that stars don't hit each other, stars don't merge. No, they do. They totally do on a regular basis. This is one of my favorite updates to our understanding of the universe. But it takes just a moment to merge. And the flash of light, the dust that's dissipated, the shock waves traveling through space, they don't last very long. And this is why there's only one of them that has so far been near enough and bright enough that we have been able to see it. The way this is explained by Don Neal, a research scientist at Caltech and a GALEX team member, is it's like catching sight of a baby when it first walks. If you blink, you might miss it. This is this new star's moment of fluorescing as it goes from 2 to 1 and settles in to its completely new format in the sky. We got lucky with this one, and I can't wait to someday have a bigger and more sensitive ultraviolet telescope out there looking for more of these fantastical nebulae.
From the ultraviolet in a telescope to the tiny, tiny zircons in a microscope, our news looks from the big sky to Mars. Black Beauty is a Martian meteorite that was found in Morocco in 2011. Recently, scientists sampled about 15 grams of this rock, ground it up, and found 60 zircons. Zircons are great for dating the age of older objects. Everyone knows about carbon-14 and how we use that to date things that were once alive. But carbon-14 has a relatively short geologic half-life. So we look to other things when it comes to dating objects that are solar system age, like Mars. In this case, they managed to find 60 zircons in their sample, which is pretty huge since we didn't really expect to find any. The ages that they got are mostly around 4.5 billion years, which is what you would expect. However, several of them are in the 1.5 million years to 300 million years. Sorry, 1.1500 million years. Let me try that again. 1500 million years down to 300 million years. The rock apparently comes from the southern hemisphere of Mars. There are no volcanoes, and zircons tend to form under volcanic conditions. Martin Pizarro, lead author, said, "These young ages were a great surprise. The Black Beauty meteorite is believed to come from the southern hemisphere of Mars, which does not have any young volcanic terrain. The only possible source for these young zircons is the Tharsis volcanic province located in the northern hemisphere of the planet, which contains large volcanoes that were recently active. And by recently active, we mean geologically. Think of it this way: the volcanoes in the northern hemisphere are huge. They are the biggest volcanoes in the solar system. They can get up to 21 kilometers high. And that's because they're kind of formed similar to how the Hawaiian volcanoes are formed. Hawaii sits over a hotspot, and liquid magma rises up basically directly from the mantle. There's no plate tectonic action involved here. It just wells up, breaks through the ocean floor, and then builds until you have islands. There's one off the coast of the Big Island that is currently forming. It'll break the surface in about 10,000 years. In the case of Mars, though, we don't have plate tectonics, so that hotspot doesn't move. So instead of getting an island chain that works its way across the surface of your planet, you end up with 21-kilometer high volcanoes. But they're in the northern hemisphere, not the southern. So how did this work with this rock? Without plate tectonics, these younger zircon crystals must have come from deep in the planet's interior. This reservoir was previously unknown, so we've found something new. Mafalda Costa, co-author of the new study, explains, having samples of the deep interior of Mars is key. This means that we can now use these zircons to probe the origin of the volatile elements on Mars, including its water, and see how it compares with Earth and other planets in the solar system. We've basically now been given one more possibility for that planned sample return mission. If we could find some more zircons, get some more ages, we could piece together a history of another planet. And that's pretty exciting news.
We had to start with some beautiful science, but not all good news is good news. After all, it is 2020. While we were preparing this episode, it was announced by the National Science Foundation that the Arecibo radio telescope, which has recently suffered a pair of cable breaks, will not be repaired. As those of you watching the show last week may remember, when the second cable snapped, I was concerned that this would be the death knell for the scope. And I really wish I'd been wrong. Here I'm going to read from the press release and let you know we will be bringing on observers for a future episode or special event to memorialize this great facility. From the release, quote, following the review of engineering assessments that found damage to the Arecibo Observatory cannot be stabilized without risk to construction workers and staff at the facility, the U.S. National Science Foundation will begin plans to decommission the 305-meter telescope, which for 57 years has served as a world-class resource for radio astronomy, planetary, solar system, and geospace research. The decision comes after NSF evaluated multiple assessments by independent engineering companies that found the telescope structure is in danger of a catastrophic failure, and its cables may no longer be capable of carrying the loads they were designed to support. Furthermore, several assessments stated that any attempts at repairs could put workers in potentially life-threatening danger. Even in the event of repairs going forward, engineers found that the structure would likely present long-term stability issues. NSF prioritizes the safety of workers. Arecibo Observatory staff and visitors which make this decision necessary, although unfortunate, said NSF Director Sithraman Panchantharthan. For nearly 6 decades, the Arecibo Observatory has served as a beacon for breakthrough science and what a partnership with the community can look like. While this is a profound change, we will be looking for ways to assist the scientific community and maintain that strong relationship with the people of Puerto Rico. End quote. I have to admit, going to Puerto Rico and exploring this site was on my bucket list. I'm lucky I've gotten to do many of the things I've dreamed of doing. But I'd always wanted to walk under this dish and see the fossils I've heard are embedded in the rocks. Now, well, I get to live vicariously through the memories of others.
Oh, not a great way to start our day, guys. Moving back to Mars, we included in our Minecraft version a potato farm because of Andy Weir's The Martian. Now, scientists have challenged the possibility of farming on Mars. Researchers planted lettuce and a particular weed in different kinds of dirt. They chose dirt that either looked like Martian dirt or was like Martian dirt. It's simulated, of course. 2 of these samples came from minerals in Hawaii or the Mojave Desert. Those are the ones that look like the dirt on Mars. To mimic the makeup of that Martian dirt, they built their dirt from scratch using volcanic rock, salts, and other chemicals that Curiosity has found. While the lettuce and the weed survived in the Mars-like soils from Hawaii and the Mojave, neither grew in the synthetic dirt. This is all covered in a new paper in Icarus. So the reason for this, soil here on Earth has microbes and organic matter, and all of these help plants grow. Mars dirt is crushed rock. This basically says that you're going to have to transform your Martian dirt into something more usable if you want to grow plants there. So the seeds of these 2 species germinated, grew in the dirt from Hawaii and the Mojave Desert, but they still had to be fertilized. Nitrogen, potassium, calcium, other nutrients. Nothing in either one could germinate in the synthetic dirt. So you'd have to use hydroponics. They gave them the fertilizer in the hopes that maybe this would work, and the seedlings died within a week. So transplanting them didn't happen either. So then they looked at the dirt and they thought, all right, what's wrong with it? Why doesn't it work? Okay, the synthetic dirt from Mars has this very high pH level. It was about 9.5. Meanwhile, the 2 other soils were at a pH level of 7, which is pretty neutral. So they treated the dirt, the synthetic dirt, with some sulfuric acid, brought the pH down to 7.2, transplanted their seedlings, and they got an extra week before they died. So then they discovered another problem. The original synthetic dirt recipe did not include calcium perchlorate, which is a toxic salt that is said to make up about 2% of the Martian surface. So they added the concentrations of that, and then nothing grew in the dirt. It's not looking very good for Mark Watney and his potatoes, guys. There's another experiment that's currently running at the University of Georgia, and they're using several different kinds of synthetic dirt. I think there were 8 different samples that they're trying. And so far, there's a plant called mothbean that seems to be doing okay. But again, the results here still aren't looking very promising. We're going to have to work really hard if we're going to set up some sort of self-sufficient Martian base. Not the greatest news this morning. Not as bad as our previous story. But we still have some more work to do before we can colonize anything.
Okay. Yeah, I'm going to go back to the pretty science because we need pretty science sometimes, and I clicked the wrong picture. All right. Here we go with pretty science number 1 of 2. In other enigmatic news, an atmospheric phenomenon called Steve has once again proven it is not related to aurora. A number of years ago, astrophotographers noted that there are weird yet beautiful ionization events in the atmosphere that look like aurora at first glance, but in all reality are unique in being a combination of a bright streak of often purpley glow coupled with green pickets of light from excited oxygen atoms. The name Steve was backronymed into a lot of fancy science words. Literally, folks decided Steve needed to stand for something. So Steve stands for Strong Thermal Emission Velocity Enhancement. But the truth is, this is just light called Steve. Now, this phenomenon is one where we really have to credit human curiosity and the drive of everyday astrophotographers to know what it is that is appearing in their photos, because it's not what they're used to. As our technology has gotten better and better, everyday people have been able to capture more and more amazing photos of the night sky. And regular aurora have beautiful classical explanations of the interplay of particles from the sun hitting the Earth's atmosphere, cascading through it, and generating various bands of color as they move and dance. It's well understood. You can take movies, everything makes sense. And then Steve appeared. And Steve is not always located when there are aurora going on. And so the astrophotographers went to scientists and said, look, we want an explanation for Steve here. And this is the thing. And here I'm going to quote Joshua Sematar, a professor at Boston University and first author on a new paper coming out in the AGU Advances Journal. And he says, not entirely sure about anything with respect to this phenomenon just yet. You have other sequences where it looks like there is a tube-shaped structure that persists from image to image and doesn't seem to conform to a moving point source, so we're not really sure about that yet. This is a really weird phenomenon, and it's gotten weirder. Looking at this image, you can see there's that beautiful purpley, in this image it looks pinky, streak of light, and beneath it is a band of green. And it was temporarily thought that these bands of green might be from some sort of a rising plasma effect. But if you zoom in on these green bands, you will find that they have little hooks. They have feet. And this is not consistent with an interaction between rising plasma balls and the Earth's magnetic field or anything else. So all of our prior understanding that we thought we had has now been thrown out the window. Steve is deeply, deeply confusing, but we now have more observational data telling us more ways we do not understand Steve. So, these astrophotographers who have become scientists in their own right, studying this phenomena, they have done awesome work, perplexing all the PhDs out there who cannot explain what's going on. Here I quote Elizabeth MacDonald, one of the co-authors on this study, who wrote, "Citizen scientists are the ones who brought the Steve phenomenon to the scientists' attention. Their photos are typically longer time-lapse than our traditional scientific observations. Citizen scientists don't get into the patterns that scientists get into. They do things differently. They are free to move the camera around and take whatever exposure they want. However, to make this new discovery of the points within Steve, photographers actually took shorter exposure photographs to capture the movement." And so here I want to stress again, these are astrophotographers who were out there doing their astrophotography awesomeness, saw something, did their best efforts as a scientist, demanded that all the PhD researchers get involved and help them figure out what was going on, named it Steve. And now no one understands what's going on, and we have an entirely new phenomena because all of us are scientists. If we take the time to notice what's around us and share what we find. Steve is awesome. And bottom line, because Steve has feet, we have no idea what Steve is.
I'm going to take us back out into the solar system. This time we're going to go to Enceladus, another one of my favorite little icy moons. The ice in Enceladus is thicker over the northern hemisphere than over the tiger stripes in the southern hemisphere, which you can see are 4 parallel lines. This isn't really surprising. What's kind of surprising is scientists have maybe possibly in a lab, figured out why. I'm going to quote from the article here. The idea of thinner ice around the southern pole is certainly not new. Observations from Cassini revealed that the moon's ice is thicker around the equator and thinner at the poles, especially the southern pole. But previous studies have failed to simulate the formation of cracks that resemble the tiger stripes. Those studies focused on what happened when gravitational tugs on the moon were at their strongest. The new study considers the breaking point of the ice itself. See, Enceladus is pulled on by Saturn, but it's also pulled on by the other moons, similar to what we see with the Galilean moons at Jupiter. They pull on Io, Io becomes volcanic. They pull on Ganymede, Ganymede has a liquid ocean. It just works. This could cause different amounts of stress on the icy shell of Enceladus, depending on what pulls where and when. Even when the moons don't line up, passing each other in orbit, tidal stresses and variations are still active. However, we still can't fully explain that tiger stripes phenomenon. First author Alyssa Roden said, one of the challenges of Enceladus is that if you can make fractures at the South Pole with low stress, you should make fractures at the North Pole with the same stress. You have to have a reason that you don't see it at the North Pole. So Roden and her colleagues modeled icy shell structures and tried to see how they would react to the different poles of the lunar tides and Saturn. The ever-present tugs created stripes most effectively when the ice at the southern pole was considered to be less than 5 kilometers thick. The North Pole likely reaches a thickness that's more than 10 kilometers, so it's prevented from breaking. Previous studies relied on recreating the amount of pressure applied to the ice, while this study focused on the failure strength of the ice. This strategy allowed researchers to finally simulate Enceladus' striping. Of course, these are laboratory experiments, and assumptions had to be made about the structure and the composition of the ice. The actual ice might have a different resistance or contain more material from Saturn's rings. There could even be a hidden impact structure. We need another mission to Enceladus. We need more missions. We need more science. Some of these things just can't be done in a lab and answered to 100% satisfaction. We have to get out there and we have to take a look.
But we're not going today. So instead, we are going back to more pretty pictures. I told you there was going to be another one of these. So models are awesome, especially when coupled with pretty pictures. And I've now got both. So there are times in science when you look at something and realize it's super complicated scientifically, and then you try and figure it out. Cream mixing into coffee? This is a super hard problem to figure out, and it's earned a bunch of people degrees and publications. This image, with waves of color capturing atmospheric waves, it has earned some folks a really awesome publication. This photo was taken in 2016 and captures a disturbed atmospheric layer 90 kilometers above the El Leoncito astronomical complex in Argentina. At this altitude, oxygen can produce magnificent sky glow under just the right combination of sunlight and magnetic field activity. And here we see what happens when those effects occur in combination with thunderstorms off in the distance. Now, to me, one of the most confusing naming things in astronomy is gravity waves and gravitational waves. These are two radically different phenomena. Gravitational waves, which we discuss on a regular basis here on this show, are created when very massive objects combine and release a lot of energy in the form of gravity that is stretching and compressing the entirety of, well, the universe as it propagates through. That's a gravitational wave. You get Nobel Prizes when you find those, or at least when you're the first to find those. Now, gravity waves, this is what happens in fluids, and our atmosphere is essentially a fluid physically when you displace it away from equilibrium within a gravitational field. So when you see those gorgeous cloud patterns where you just have rolling clusters of waves that often appear as stripes through the sky, those rolling clouds, those are created by gravitational waves where something has displaced the atmosphere, set up standing waves as the atmosphere tries to return to equilibrium. And it's within these waves in the atmosphere that those clouds form. And I didn't mean standing waves in the scientific meaning of standing waves. I meant it in terms of you see these standing blobs of cloud moving through the sky. Words are hard, people. Words are hard. So gravitational waves, they can happen in water, they can happen in the atmosphere, and all it takes to generate gravity waves is a displacement in the fluid from equilibrium. And it turns out thunderstorms can cause displacements throughout large columns of air that act like a hammer hitting the atmosphere and driving these waves over great distances. And in this case, also with great beauty. So here we see those waves of different density in the atmosphere interacting with the magnetic field and the sky glow to create these orange bands, all captured in curving glory that is due to the fisheye lens from this photo. And it's just kind of awesome. And my congratulations go out to author Steve Smith for having today's prettiest science story and what may be this year's prettiest science story as far as I'm concerned. This work appears in the journal Geophysical Research Atmospheres.
All right, I'm back to planetary science away from Earth. Finally, 14 years of work has culminated in the completion of a new instrument for the Jupiter Icy Moons Explorer mission, JUICE, from the Swedish Institute of Space Physics. This instrument will measure particles around Jupiter and the three icy moons Europa, Callisto, and Ganymede, and contribute to the large puzzle that needs to be put together to understand this complex system. From the press release, Stas Barabash says, icy moons are the most exciting objects in the solar system to study. The dream would, of course, be to discover a small crack in the ice of the moon Europa, through which water from the sea under the ice squirts out. Maybe it's a favorable environment for life under the ice. To fly through the cloud of steam, measure in it, and succeed in identifying some kind of trace of life, that would, of course, be fantastic. Oh, I'm sorry, I just love that quote because I think it sums up how we all feel about looking for life in the Jupiter system. Engineers had to figure out how to combat Jupiter's intense magnetic field, and they compared it to being in the middle of a collapsed Chernobyl reactor for a short time. They've succeeded, and they've accounted for that. So now that particular instrument gets to go and actually be placed on the craft. And we'll continue to bring you updates as this mission moves forward. This has been The Daily Space.
Today's episode was written by myself, Dr. Pamela Gay, and my co-host, Beth Johnson. Engineering is provided by Ali Pelfrey, and web content is produced by Beth Johnson. You can get a complete transcript, show notes. Well, there may not be a transcript today. You can get complete show notes and see images related to each of our stories at our website, dailyspace.org. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people like you. We know 2020 is hard. We know a lot of people are really struggling. And to those of you who continue to allow us to do this, thank you so much. The fact that you're doing okay means we're doing okay. And your donations are carrying us forward, and we're all going to make it into 2021. To learn more and donate today, please visit our website, CosmoQuest.org.